All right. Thanks, George and Rob and Tom. Good to see you all. We're in knowledge engineering, at least entering from there. Anything that people want to bring up for today, or we'll go to the projects or bring up some other random stuff. Here's one knowledge engineering kind of entry point. This is going to be in 2 hours from now. This is a live stream that I'm going to do with Jerry Mikowski, who has we'll clarify. I'm just not remembering right now if he started this or if he was one of the main people. But the brain for a long-standing mind mapping type knowledge management software. So I kind of almost purposely haven't looked too much into it, but figure that we'll talk in a few minutes. But yet another interface. So I mean, I guess to kind of open it up, what do we ask somebody when they present their knowledge engineering interface? Like other than just sending George's textbook or something. Like as there's so much things that have been done, extant databases and platforms and methods. I mean, what is the move? How to make this a useful conversation beyond just like, oh, cool, nice notes. And how to work towards a broader contextualization, if not like synthesis with all these different things.
Well, look, I've got an idea. It's forming. It's not quite, probably not ready for prime time. But I've argued all along that knowledge is the structure of a system. And the structure of a system determines what that system is going to be able to do ultimately, and makes it feasible to process new messages for information. Um, so one approach might be to consider knowledge as a system and try doing a systems analysis of the knowledge that we presume to have. I see this whole thing tying all together. So Rob and I and Shanghai and others met yesterday for the GST SIG organizing. And general systems theory is like the top level, if you will, ontology, and then it all branches down from there is what systems are, but also we can look at it from the standpoint of knowledge, well, maybe call them chunks, I guess. But you see this in Tom's UML diagrams, that there's really this relation that takes place. And if it's following principles, and here I'm saying the principles ought to be those of system science. If it's following principles, then the accessing of the knowledge when you need it should be fairly straightforward. You don't have to do a massive search. There can be a oh, what do you call it? Well, the word's in my head somewhere, but I can't get it out. So I'm having to do a massive search. Anyway, that was just a sort of a random thought, something to think a little bit more about, and it might supply a principled way to go about this whole knowledge engineering thing. And what I'm actually, let me take that one step further. We're not going to rely on the nature of a tool or tools to develop a knowledge structure. Rather, we're going to have a principled systemic way of structuring our knowledge, that we will use the tools as we see they will apply to that. Does that make sense?
Definitely agree with what you've been saying. Um, the emphasis is on having that deep foundational principled upper ontology, which so closely maps to reality that it has a good fit for all the lower ontologies that also have that same approach. And yeah, the other side of the coin that you mentioned about not being tool orientated, but being tool independent. It is the data and the knowledge that's the important thing. And the only bit I'd add on would be it then becomes a question of coupling different ontologies or systems together through some sort of data protocol, so that you can just ship the data around to multiple platforms and multiple tools, but the real value is in soundly constructed principled data and knowledge.
Right, right. Yeah, when I wrote about interfaces being necessary to describe boundaries of systems, what makes an interface different from just all the other ordinary processes or subsystems is that it contains a protocol for exactly what you're talking about. But it's a protocol for any flow, matter, energy, messages, and so forth. But that has to be well defined in order to make the thing work, make it exchangeable.
There was a big initiative around about the year 2000 called CHANS, because they had a lot of funding, coupled human and natural systems. So it is about coupling all of these, not only systems, but different realms together of the nature. This is all the realms of reality that we kind of acknowledge in system thinking, in system theory, is, the natural systems of material aspects around us, the living systems, and then the human systems. And it's coupling all of those things together in a cohesive way.
Thanks. There's a ton here. Like I'm trying to color the words a little bit because I feel like there could be some sort of syllogistic sentences. Like George, you began with knowledge is the structure of a system. Okay, then if the purpose of a system is what it does, which is like a functional teleology or like a local or approximate teleology, then so if structure if purpose is what it does and what it does is what it is and what it is knowledge, and knowledge is just figuring out some of those key distillations. Those are and understanding them as just English representations as part of a multiple language. Then the upper ontology, yeah, that reminds me of the sumo upper ontology. And the upper ontology has been stable in size, like in lines of code for many years. And all the work continues on the mid-level ontology because the upper ontology, like before is before, after. Those kinds of logical relationships are just kind of fixed relatively. Then the knowledge chunks, I also don't know what to call that, but it reminds me a lot of some of our earlier discussions on language models. Not to go into it, but like we talked about how if you concatenated all the documents, you'd be learning context that was inappropriate. If you broke up the documents into words, of course, you wouldn't have any semantics at all. It would just be a word list. So the question is like, what is the size of the concept such that learning within those bounds is contextually coherent, and then learning across those bounds there's like a diminishing return, um and then it just also reminds the interface and boundary and all that comes along with that. That's going to be big. Like I'm in the IEEE working group for the HSML HSTP hyperspatial markup language and transfer protocol. It does have some category theoretic components. It's not done, and I don't know like how rich the standard will be versus like what is left to the end engineering. But at least um analogously to HTML, HTTP, and then we had to go build the web. But there was a transfer protocol and a markup, and they're looking and thinking more about like the spatial and the semantic webs, which is very like Internet of Things, etc. And I think systems is like the ether that all of those could even exist in. And in some ways, but it's also the next upgrade after spatial temporal, space and time just being certain things. And to really test the deep analysis method with very challenging systems like knowledge as a system or group knowledge as a system or a concept as a system, those would be very informative too.
Yeah, why not?
Sorry, go on, George.
Well, all I was going to say is on the chunk thing. Um, in my analysis of thing representation or process representation in the neocortex, and I focus on the neocortex because that's the most malleable modeling machine that we've got. That I used the term concept to designate a chunk, but then concept is a system, and concept therefore is built of subsystems, and each of those subsystems can be. So if we look at, for example, a visual, if you close your eyes and imagine a horse, for example, you're actually driving down into the visual processing areas of the brain that come out with all of the features and relations that exist in the mapping of the vision of a horse. But the upper concept itself is just horse. Could be any kind of horse. So anyway, the chunks that I'm sort of thinking is this notion of concept, subconcept, sub-subconcept, and so forth, as I believe it's done in the brain.
When you're how do you initiate analyzing a concept as a system?
Well, I guess I would do it top down. Just the procedure that I wrote about is to start with the system of interest. So technically, you could start with any concept and work your way down. What constitutes the parts of that concept? What are the inputs to it? What are the outputs from it? Those are the linkages that would occur between. So, for example, you got horse is in the hierarchy of it's a kind of mammal. The mammal is a kind of animal, and so on. So we got this classification hierarchy, but at the same time, there are different kinds of horses. So we've got a sort of a lateral linkage between Clydesdales and whatever other kind of horse there is. And then further linkages to things like ponies and donkeys and so forth, because they have similar body forms. So then you basically decompose that concept into its component bits and pieces. Now, all of this is off the top of my head. Remember, I'm not copying anything.
Of course. Well, it is from the top of the head. Um,
There's two different
Yeah.
types of relationships it's often not clear between the two. One is part and whole, and one is type and subtype.
Mhm.
So I think you're talking about type and subtype with
Well, I'm talking
horses.
about both. I'm talking about both. Yeah, it is type and subtype, but it's also part and whole. So the categorization hierarchy, for example, is a kind of linkage, right? The part of well, let's take that a step further. So a part of the horse would be its, say, its torso, or maybe easier, a leg, right? And so all of these animals have legs, so there's linkages across there, but the leg is a part of any one of them, as opposed to the whole concept, which is a horse or donkey or whatever. And then the leg is linked, the concept of a leg is linked also to other kinds of animals that have legs, dogs, chickens, and so forth, with the appropriate modifications of the features. So it's a web. It's a really complex web. But the way I think we get around it is the upper level, if you will, concept, say horse, then generates all these low level the parts of the horse to get that vision of a horse. But at the same time, you're linking out into the web of other types of parts, if you will.
Yeah. This is a wait. Want anything? This is a big point that comes up in again in sumo. This is just the upper ontology that I'm most familiar with, is and it's a fundamental limitation of the more annotative descriptive type ontologies, like the ones that are stored in the OWL file format, because they are just directed acyclic graphs. There is often a fundamental ambiguity whether the parent-child relationship is part whole or type subtype, because Clydesdale is a type of horse, but leg isn't a type of horse. It's a part, but it's a type of body part.
Right.
And so, but when the edges are just labeled with English words like is associated with, is a part of even, then basically the parent, like the 5 generations of the parent child comes to be loose and meaningless and associative, because you could say, well, the Toyota is a brand of car, just you end up just being able to take it anywhere, versus in sumo, again, the upper ontology only describes logical and higher order logical relationships and meritopological relationships and things like that. And then, like, there may even be horse, but here's car. It'll be and then here's where the functional aspects of car are declared in these Lisp-like programs, which can be checked for theorem completeness, and also the English words aren't doing any work. I is an instance of an internal combustion engine, but then you can have another language and just flip out the variables for instant localization. So what ends up happening in a lot of the work that we've seen is, even where there is a formal ontology, because of systems that leave a lot of the semantics outside of the formal system, then the formal system itself becomes kind of brittle or contextually relevant, like a loader, but it doesn't carry an internal semantics, like, which has to be done with these programmatic axioms that are executed. Because building into the system the difference between parse wholes and type subtypes, especially when we're talking about immaterial phenomena. Like, yeah, we can definitely explore and like debate whether the systems analysis of horse as a concept should include like the material substrate. It should, but of course, reductionism is the viewpoint that that material substrate would explain the concept of horse. So, moving away from pure reductionism, there's some elements of the systems analysis that it's going to reveal something about the parts of horse that aren't going to be described using brain anatomy. And then another interesting thing is, let's just say we did instead of horse, like how about the word a or the or something like that, where it doesn't even begin with a kind of external reference.
Yeah, the determiners are not, oh, funny thing, talking about meaning and semantics and so forth. I have been reading Ray Jackendoff's Foundations of Language, and I just got to part 3, which is about meaning. And this is a traditional problem in linguistics, is tying semantics to or trying to get semantics out of syntax. And he's argued that no, it doesn't work. That they help each other, but they don't make it. But anyway, getting back to I think he calls it a non-word. It's the determiners, the, this, a, and so forth. They don't really, they're only pointing to the words that count, something like that.
Also, John Dewey goes into just unreal detail on these words. It's kind of what made me think about it. Like, all the difference in the logical expression is like it gets loaded onto a or the this person is tall, people are tall, a person is tall, no person is tall. Like, those are the real moves that change the universal into the existential quantifier and completely establish the empirical basis of the inquiry, which is everything for the pragmatists.
So this is a big concern or worry or uncertainty for me. We're very good at managing the chunks, the spatial temporal, the thing representation, but we're not very good at capturing and in software or in ontologies the different frames, the almost infinite number of frames that you can have on a particular chunk. So, for instance, if we were chunking people, 50 different people, one person might do something, but how do we capture the framing or the perception of the 49 other people of what that person has done in an ontology and in a computer? And so I think all these ontologies are not very good at capturing context or frames that go on naturally, in reality, just by sheer cause and effect, multiple process. Every single object is almost a multiple processor of its own impact in reality. And computers are not that at the moment. And we don't even, and there's very few ontologies which capture frames, that they just assume one narrative going through or perception, and work on that and constrain it a lot like that. So, that I've yet to see ontologies and software and databases really capturing this context aspect successfully in real time sort of processing ways.
Thank you. I agree. Have also haven't seen it so much externally. But again, maybe to the original point, maybe it's not going to be realized externally. But I totally agree with this. This is like the quantum free energy principle perspective, or just the quantum information. And what gets implicitly baked into an ontology, unless it's careful otherwise, is a kind of essentialism, absolutism, um, hegemony, singularity, etc., mono perspectival, because it's like, well, horses have 4 legs. Oh, okay, well, this one has 3, and this one has 5. And so it's like, well, then it's not a horse. Um, and then, like you said, the 50 people in the room. So like Mike Levin and et al. have this kind of poly computing. Like if you're looking at a process, biological process or a computer process, let's just say it's fully encrypted, you can't distinguish it from noise. So that person, if they don't have a relative ontology, they just dust up, oh, okay, it's just noise. But really what they could have said was, with this context that I brought to the analysis, it was noise. So it's the same exact statement in that instance, but then they come back with a different piece of information. And then there's no incompatibility between, on day 1, it was noise. And then with this different context on day 2, here was the semantics. And then it's like, and that semantics is a received semantics. So the claim isn't that that's what it says, because that's absurd.
Yeah, it was just the
But
framing at that time. Yeah.
yeah, and so I think like and what will be really interesting, um and strikes at some of the heart of the system science questions, is like all the stuff about like monad and unity, and then unity is plural at minimum 2, and kind of system and subsystem, which is like, okay, we know that there has to be a fundamental relationality, and there has to be this fundamental unity of system. System has to exclude non-system, and system has components. It's relational, but then we're relational in our modeling of the concept of system. So in what ways is the GST more like the elephant in the room? And in what ways is it like general systems process? Or maybe they're just both needed to be clarified. Otherwise, GST will, even in its generality, still be singular.
It all depends how you define system and GST, obviously. I mean, for example, below your cursor, you have the question you post, how to initiate analysis of a concept as a system. I probably wouldn't even phrase it like that. I'm coming from holism, the Smuts holism. I would just see the system, the concept as a system, what we're talking about, whether it's a horse or an elephant, is outside, to mix metaphors, Plato's cave. And analysis is just what shadows we choose or can see on the cave walls. The words that I'd rather use is appreciate the elephant, or appreciate a systems appreciation, appreciate the horse, appreciate the concept, because it's recognizing that we'll never probably analyze it beyond just seeing the shadows. But it's not about analysis of parts and subtypes. It's more about, well, this is a horse in its own right, or an elephant in its own right. What can it do? What does it want to do that we can't even imagine or know? It's its own agent. So, that's why I like the word appreciation, because it's closer to Smuts holism, but just about appreciating a thing for what it is rather than trying to break it down or analyze it.
That's great. That makes a lot of sense. It reminds me, I don't remember who in the ISSS, but there was the AIC, appreciate, influence, control. And that's not a progression. I didn't interpret it. It's more just like a kind of different stances. And then there's a strategy, or like a question about, for this system of interest, am I appreciating it, influencing it, controlling it? What am I of those, and which ones am I happy with where I am? But like, it's a great reframe that that we can always pull back to systems appreciation, appreciate the sunset, appreciate the waves. it's not like analyzing wave as a
Mm.
system. But if we wanted to analyze wave as a system, you know, where's
There
George
was
at? And all that. But to appreciate it is a different mode that complements it.
there was a 2000 survey of about 30, 40 different methodologies. And it was found that the most influential was probably Bloom's taxonomy. And half of Bloom's 6 can be thought of as analytical, but the other half are more synthesis. So evaluate, create, apply isn't trying to analyze and remember the data, the bits underneath it, but it's more about just recognizing the whole and what is its relationship to other things in the world, in reality. How can we apply it? How can we evaluate its relationship? How can we create new things with it? So that's where you get both sides, appreciation a thing for what it is, but also a thing for what it could be and its potential.
A fair amount of attempts to model system types and whole part relationships. And I started with the whole part relationship because it seems to me that's empirical. So there's not really a lot of question about whether atoms are parts of molecules and so on. So they can be modeled, and I would think people can come to an agreement about them. But I also did types where part whole is empirical, types are not. You can organize something in types in a lot of different ways. So you could do automobiles, for example, by size, by type of engine, by expense, by color, all these. So this is one of the things that you can do with a model that you can't easily do otherwise. A lot of cases, people have one way of doing subtypes and don't recognize the other ways because it's hard to do multiple ways at one time. So I see that as an advantage of models. I also see the relationship with living systems. So there's the hierarchy of types that's been developed for hundreds of years and still changes. And if they are living systems, then there's more general type of system of which they are a part of. So that all fits together. So we're just trying to generalize more than is done with the living systems in Earth. So anyway, I have a lot of presentations that I've done for those. I'll try to pull one together and send it out so you get some idea what I did.
Thank you. That sounds awesome. Yes. Okay. Late breaking agenda item.
Thank you for the instant recognition.
Overruled.
Late breaking interjected in. Sorry to change the agenda, previous topic slightly, but I did want to ask this group for help in some sort of platform or software for helping to manage a spreadsheet of GST candidates. So this is where people can nominate different general systems theory candidates, from Aristotle to Plato to Bertalanffy and Miller's living systems, and then more modern authors now, or researchers now. And it's on a spreadsheet at the moment, but I want to sort of automate it so that people can add an entry and have a status. It's just sort of like been nominated and then a workflow to process it. That's relatively straightforward. But what I'm after is that a way to capture, for people to contribute and capture feedback and comments, very much like requirements engineering and systems engineering. where every comment on every aspect of a plan or aspect is recorded in some way, so that there's an audit trail to go back and say who suggested that, what is that comment, how does it affect things, and having to sort of spin out sub discussions on that. My question to this group is, does anybody know of an existing software or platform that can take and capture comments and feedback like that, if I've explained it well enough?
I've been away from the field too long. There's software out there today that I never would have imagined.
Not to be a one-trick pony elephant, but you know what I'm gonna say. Um, if you shared even the headers and like 1 or 3 rows of your data set and just a few things that you'd want to see, let me try to mock up in Coda some of these just to explore, because like one way that that comments could be, so let's just say these were GST1, GST2, GST3. I don't like it. That's one way. And then there could be another view that's more like spreadsheet. It could be all in Coda, or there can be two-way sync with a Google Sheet. So there can be the base information in the Google Sheet, and Coda can be used as a one-way or as a two-way, just for those kinds of visualization and commenting affordances. Find that the saved sheets or Google Sheets, the comment threads, and they're just getting resolved and things like it, just kind of hard to stay on top of. In the end, it does depend on who's using it for what and what stage, and then also just like what trade-offs in that kind of crowdsourcing. Like, if you're not concerned that the people who have access could delete a row, then you could work with a system where everybody has edit access. Okay, but now if people only can comment, well, you could pull back to that level in Google Sheets or in Coda, where everybody can comment. But then there's a level of, okay, well, now can everyone comment? But what if someone just comes in and just does, with the language model and just does 100,000 spam comments? Not saying that would happen, but just what kinds of things are you actually looking to do, and so on. But I'm happy to make some visuals or anything like that.
Do you, off the top of your head, do you know if anybody's done anything close as an exemplar or using Coda to Google Sheets in that way?
Don't
have to answer
I mean,
straight away. You might come to you.
let me show. I'm just going to another window to get a Google Sheet that I can that will be
My
okay
second
to
question
show.
would be then, are you available for hire?
I'm available for free.
I've used UML to capture notes and questions and issues. So you can define a class as a note or an issue or a question or whatever, and then define instances of it, keep it in the model with everything else, and then eventually resolve it over time.
That
Okay,
sounds like the best option, but very challenging to work with.
Yeah, we're going along the spectrum of build it ourselves, using either coding or plug and play, or there's something out there already. So
here's
go.
Here's one. This is the simplest way, is just add. This is an embedding to another GDoc. So this is just, but it's also editable. Or maybe not. It's not directly editable from here, but you can just pop over. But for viewing and for commenting, or we can see if we can let's see if we can pull in a sheet.
So for any particular cell, if you wanted to change something, you'd put, it would record who's changed it, why, what the previous version was. You could roll it back if necessary.
Yeah, the audit record. The audit record would be recorded, I mean, either in Google Docs or in Coda, whichever one, it would be all there. It might be a little bit hard to dig back through. It's because like the interfaces for the history, unfortunately, are not great. Like the like a dream solution would have clean interface just like these high-tech platforms do, but on the back end would be like systems language, sysxml, XML, UML, like Tom just mentioned.
Yeah.
So that all the operations, the actual semantic kernel of the work, which includes comments as well as like primary material, all of those would be like first-class citizens. And then there'd be the visualization, which could just look exactly like this, or it could just look like whatever.
Okay. I will take it away and think about that. This Coda come spreadsheet integration, and I will relook at this recording that you've done on the fly, and see.
And if you send or if you send a Google sheet or just even what the headers look like, that could be fun to test and explore.
Okay.
But yeah, especially as the rubric or the scheme will probably also evolve a lot. So it's kind of like you're building out rows as you just, and then building out columns and kind of filling in and revisiting. And then maybe, yeah, so, but what's so funny is what is your Fermi estimate? Just order of magnitude. How many such spreadsheets do you think there are in the world of people who have tried to list their, 20 to 1,000 systems frameworks that they're aware of?
Oh, it's a specialized field. So on that specific topic, very few, maybe one or two, three, if that's what you're asking.
Okay, I guess at a higher estimate, I would say that several hundred efforts have tried
Right.
to compile like a reading group or a research lab, or just a hobbyist systems researcher have, or just someone who read George's book closely. It
Yeah.
just, and so like soliciting that, there's no way to communicate it other than like what we already do per se, but like it just, this is and just to bring together people's systems, resources, and notes,
Well,
like the
I'm
ones
going
that they
to,
want to contribute. We could accelerate our research a ton because there's many hours of critical research that's been performed, and much of it will be sunsetted unless there's a way to donate it credibly.
so I've just posted the link. Oddly enough, it was from Shingai's notes that from minutes from a meeting that he put on Coda. But that link that I've just posted into the chat is the spreadsheet.
Okay, awesome.
I've been collecting some of this stuff for years, including definitions of system, of which I have several scores of types, various other related things. There's a ton of them out there, and I think one of the things we should be doing is coming up with a standard reference set. One of the
There are
problems is
ontologies for that.
they have different names, And so there's confusion because of ambiguity of the names. So we can't even talk reasonably about a lot of it.
Yeah. Well, so this was just I just in the Google Sheet, Control A, Control C, Control V. So that's and then starting here, then it's possible to already move into the comments and discussions and have multiple views and to have filtered views. And okay, here's only the ones from after 2004. Um, and then the other thing, just on a more funny note, that reminds me of the stand-up comedian convention, and first person, says joke 21, everyone laughs. Second person, oh, joke 222, everyone laughs. Third person's like, joke 171, and it's like silent. And then they walk off stage like, what happened? It's like, it's not what you said, it's how you said it. But exactly like that for systems.
Rob, I've got a question for you.
Mm.
So you got Miller's Living Systems as listed as the third one. But I don't quite get how that's a general system theory.
That's why it's called a candidate. It's what people or anybody really can nominate something, but whether it actually elevates to be a valid candidate or a valid GST candidate is what we need to have a set of criteria or classifications for, to say, according to this classification, then it could be called a GST or not.
I almost wonder about just
Hmm.
pulling back to just ST, and then G is one of the criterion that's evaluated with a certain scope and rubric, generality, including on different axes of generality. But it's like systems theory. And then if someone has a framework like liquid systems theory, so it's not pretending to explain solids, but liquid systems theory has a whole sub-ontology, and and the question then scope and gambit, where it does and doesn't apply, would be some of the fields that we would want to, where could it apply, and then like where has it applied, and the citations there, and then like make it more empirical which one's GST, because I wonder slash feel if people start debating which one is more G before there's any discussion about the S and the T, and we can just evaluate the S and the T.
I was avoiding all of that as a later stage. I have a different spreadsheet for the list of all systems, theories, laws, techniques, methodologies, frameworks, tools. So, I've been in so many discussions. Oh, is that a technique? Is that a tool? Is that a framework? Is that a theory? It's multiple things. So I kind of avoided that, but I did spin out this specific one for ones that people have explicitly at some point claimed theirs is a general systems theory. But as Tom knows, when he collected all this different database of definitions of systems, they turn out to be types of systems. And so these might be types of general systems theory, depending on what criteria or framework you are evaluating them against.
Yeah, like living systems, it's like kind of like, well, if you use it as a wrapper around, I'm not even knowing the details of what it is, just giving a charitable, let's just say it totally slam dunks living systems, including humans. Well, then we can come to understand other systems theories wrapped within this layer.
Mm.
And that's not to say there wouldn't even be something wrapped outside of that, but it'd be like many of these entry points are like they could be used to go far. Some of them could be
There's a
used to go
phenomena.
further.
Sorry, there's a phenomena I've seen where everybody thinks they're discovering general systems theory. It's like the expanding universe, everything else is redshifting away from them, so they just assume they're the center. So they start off in their core area and they come up with you know, theories around their area. Then they start to either go foundational or they go epistemological, they go abstract and saying it applies to everything. And then they suddenly say, you know, this is a general systems theory, it applies to all things. Not recognizing a few fallacies in there, like you know, the like Bhaskara's epistemological fallacy, and not recognizing that there's orthogonal aspects that other, you know, viewpoints might be orthogonal to this, so encaptured within it, but not really directly relevant to their framing of their general systems theory. So there is a lot of discussion to be had about people's attitudes to thinking they are the center of the universe and their theories are the most general of all of them, and they encompass everything. That is a phenomenon that we probably have to deal with in terms of discourse and dialogue.
Wow.
Another note is on Jamie Rose's integrity. The cell, well, the row is chopped off. I'm not sure how this is.
Spreadsheets are fantastic tools, but they do the row might be truncated, but the data might still be there.
Yeah, I don't know how to get to. Oh, all right. This is I've got the
Spreadsheet.
HTML view of it, so I can fix that later. Sorry.
Yeah. I mean, this is epic. We're in the farmer's market phase of system science with all of this kind of manual movement amongst different formats. And like just looking at a text like this and just how in 1935 and different people and years, books, terms, um no expressions of absolutism, almost certainly pluralistic compatibility, and yet the discourse environment can breed all these kinds of patterns like you mentioned, Rob, where it's like, oh well, once my systems theory includes thought, like then solipsism take the wheel. But like to be, if we were in a different knowledge environment where we could link all these alterations, where are we talking about dynamics, change, alteration, variation, etc., hinge them all on that, and then do they all agree, or what, or maybe one makes three statements after that and one makes one, but those three, you know, could have been shortened to one, or the one could be expanded to three. So like it is the co-grappling with the GST and with the process, systems process, or however we want to think about the processual elements. These are great topics. So it was a very fun meeting. We didn't talk about the other projects. This was all good. We will meet again 1 week from now. I can update. We can do any other topics. Tom, if you send something out, any other slots that people want to talk about. Also, I think it will be fun to revisit where we're at with some of the systems modeling and coding, like at the Institute and everything.
Just a
So-
quick mention, the last meeting, someone mentioned Scott Page, and it sounded familiar to me, but I couldn't place him, so I looked him up. Turns out I had taken a MOOC that he taught some years ago, and he has written a book since then. Interesting guy, but it's very general type of modeling.
Cool. All right.
On the back of Shingai starting his modeling SIG, there was discussion around Scott Page and his MOOC on model thinking.
Yes,
Cool.
smart
All
guy.
right. Thank you, fellows. Farewell. Bye.